Hello and welcome to Advent of Code in F#, day 23, part 2. So we left off earlier today with, let me share my screen. We left off with part 2 and it was not moving. So the problem in part 2 scales quite a bit. Instead of 100 moves, you have to do 10 million moves. And instead of 10 elements in the list, there's 1 million elements. And my simple little list implementation just did not cut it. So I did what I think almost everyone in the world did, and that is use a linked list. A circular linked list, so the last element points back to the first element, and then this problem becomes easy. But the tricky part, or in F# at least, the hard part is defining a linked list, because in F# you need to define something before you can use it, and if you try to loop around or make a cyclic dependency in a linked list, you'll notice that it's not actually possible in F#. Or you have to use this magical keyword, mutable, and use weird operators you almost never see, like this is an assignment operator. And then you can implement a linked list. But I love the fact that if you use the mutable keyword, the variable names or the property names, they start to like burn in your screen. It's like it's a serious danger or warning sign from your IDE that, oh my, you're using mutable data here, beware. But if you use linked lists, part 2 is actually quite feasible to do. And you can find a lot of solutions on Reddit or YouTube and stuff like that. But that's not why I'm recording this video. I'm recording this video because I saw someone on Reddit actually claim that they solved it using just immutable data structures. So no linked lists basically. And that was really interesting because my personal challenge for Advent of Code this year is to use immutable data structures only. And when I looked at their solution, so it was GitHub user rabuff, but let me go to their repository quickly. It's user Jared Summers, and he's solving the day 23 in Common Lisp, I think. That's not really relevant, but if you look at how they approach part 2, it's brilliant. They use a clever trick, which is instead of having a linked list containing all the numbers and linking to the next cup, they have a single array basically, where every index represents the cup and the value at that index represents the next cup number. So that's actually a really clever trick. And then you can play a game or do some moves, and every move you do is only updating a couple of places in the array. Arrays are mutable as well, but you have functional data structures that mimic behavior of an array and are purely immutable. And whenever you need stuff like this in F#, there is a brilliant nugget package called Fsharpx Collections. Let's maybe take a quick peek at what it offers. It offers data structures. Does it explain what it's actually doing? This is the homepage. It's not really explaining what's it about. But if you look at the API, they provide different data structures like heaps, like double-ended queues, lazy lists, non-empty lists, which have like the non-emptiness encoded in their types, queues, and one that is really interesting for our needs, because we need something array-like where we can inspect at a given index and update at a given index. And this random access list is basically that. So it gives you a log n, so pretty fast indexing and updating of elements given an index. So yeah, that's really useful for part 2. So let's maybe quickly go over the solution using immutable data structures. And before I dive into F# code, let's maybe take a look at Excel. No, let's take a look at how this works. So say you have an array I'm doing it one based, but it doesn't really matter. But the index represents the cup number. So index 1 is cup number 1, and so on, so on. And the value at an index represents the next cup number. So if you take the example, it's like current cup is 3 and then 891, on and on and on. If you look at the value of at index 3, that means like the next cup following 3 should be 8. And if you look at 8, the next cup following 8 should be 9, and so on, so on. So it's a bit of a different encoding of the state, and it works wonders, because if you look at how you do a move, it always just updates three slots in the array or in the random access lists. So this is super fast. Yeah, so let's go over the F# code quickly. So I define some custom types. So cups it used to be a list of integers, but now it's a random access list from the Fsharpx Collections NuGet package. So it provides log n updates and indexing, which is amazing. And it's purely immutable. And the state is nothing more than this random access list and the current cup, so the parenthesized number. To get to the initial state, we have to do a bit of magic. But if you have the example next to you, you can kind of figure out how to do this. So I keep a garbage element at the 0th index, so all my cup numbers line up with the indices. So cup 1 is at index 1. I don't have to do offset or off by 1 errors stuff. So that works. And with this pairwise trick, I can group the numbers 1 by 1, or like 2 subsequent numbers 1 by 1. And then I can say, okay, so the following number is this. And then I can fill it in the random access list. So yeah, that's parsing the input into a random access list where every index points to the next cup. This is exactly the same as part 1, so it's modulus calculation. It's finding the next cup based on a given cup and what the 3 cups in our hands are. These are just some functions on our abstract data type, so we don't leak random access implementation details to the rest of the code, but it's not a lot of code. It's actually only 70 lines. And move is where we did most of the changes. It used to work on lists, and now it works on those random access lists, but actually we're doing exactly the same, or we're doing the same strategy, but we're looking for different numbers because we need to update different indices. Yeah, so this is just updating a random access list, and this is purely immutable. So if I update the state here, it returns a new random access list. This returns a new random access list. So actually for every move I take or every step I make, it actually creates 3 random access lists in a row. And still, this is just as fast as the linked list mutable data structure, which I found surprising. Or just as fast. I think the linked list implementation takes 40-ish seconds, and the immutable random access list approach takes 50 seconds. I will take that today, any day, over a mutable data structure. Because even with this small example, I was getting confused because I was using the REPL and the state had changed. And yeah, so I had a lot of fun with today's puzzle. For the most part, because I learned a lot about immutable collections in F#, and thank you very much for this tip, because that's what made it click for me. This was day 23 of Advent of Code in F#. We only have 2 more days to go. I am getting a bit tired, but these puzzles are great. Keep them coming. I will see you tomorrow.